Hello friends, welcome to this third video on autocorrelation. We will be seeing a unusual problem which we haven't seen before in autocorrelation. Normally the problem of WSS involves the second part as autocorrelation. So in WSS problems already we have seen 4 to 5 problems where we have computed autocorrelation using the formula E of x of t product x of t2. So this is going to be something different from that WSS problem. So I thought we will be covering it in this separate video. So we have x of t to be a process with autocorrelation function Rx x of tau. We have the variable y of t to be defined as x of t plus a minus x of t minus a. We'll have to show that autocorrelation of the variable y, which has been given over here, can be expressed as 2 times autocorrelation of x with time difference tau minus rxx of tau plus 2a minus rxx of tau minus 2a. So we will begin with the formula for autocorrelation. We recollect the formula as Rxx of tau equal to E of x of t into E of x of t plus tau. But in place of Rxx, what we know is Ryy. So Ryy of tau will be expected value of y of t product y of t plus tau. Now y of t has already been given to me. This is my y of t. I'll be making use of this. So this will be equal to expected value of x of t plus a minus x of t minus a. So this will be my first term. I take the product with x of t plus tau. How to get t plus tau? Wherever we have input as t, the t over here will be replaced as t plus tau. And the t over here is replaced as t plus tau. So the second term will be x of t plus tau. I have replaced t with t plus tau. And extra you have a plus a minus x of the next term is t is replaced as t plus tau minus a. So this completes the second term. Now I'll have to take the product of these two quantities which have two terms in each. Therefore, when I expand it, it will be totally 4 terms which will be available for me. So we will go on with the first term with the first term. So what you will have over here, x of t plus a into x of product x of t plus tau plus a. So that is my first term. Let me take the first term with the second term. Okay, the first term with the second term. So what will happen over here? I will make it as separate term. This is positive, this is negative. So I have a negative sign. Expected value of x of t plus a, which is over here. And the next term, which is x of t plus tau minus a. So that completes my second term. Now when I move on, I will take the quantity with the second term and the first term. Now what will happen? Since we have a minus sign over here, you will have minus of expected value of x of t minus a, and this is going to be x of t plus tau plus a. So this is going to be my quantity. And the last term when it comes, it's going to be the x of t plus a with the x of t plus tau minus a in the last term. So this is minus, minus into minus makes it as plus. Expected value of x of t minus a into x of t plus tau minus a. So we are done with the expressions of all the 4 quantities. Now we will have to compare it with the formula of autocorrelation. You have x here and we have a x here. We have a x here, we have a x here. There is going to be t, there is going to be t plus tau. How is this tau obtained? Tau is obtained as the difference of these two time parameters. Now in which case, this is my time parameter, this is my next time parameter. What I'll have to do is, I can write this as r x x of tau. What is tau? Time difference between the first and the second term. So it is t plus tau plus a difference. So let me take it as minus t minus a, the time one. So this is your time 2, this is your time 1, tau is your time, tau is going to be your time 2 minus your time 1. Okay, So it is T2 difference T1. So this is my tau. So find your T2 minus T1. So we have it as T plus tau plus A minus T minus A. So now in a similar fashion, I can compute the second term also. What is going to be the second term over here? T plus A, T plus tau minus A. How I can write this as? I can write this as Rxx of T1, T2. Time difference will be T2 difference T1. So it is T plus tau is A minus T minus A. Okay. So this completes the second term. Now moving on to the third term. This is going to be your T2. This is going to be your T2 and this is going to be your, sorry, T1 and this is going to be your T2. So this is again R x x of T plus tau plus A minus T, but you have a minus sign here. So minus of minus makes it as plus. So the next term is plus. This is going to be your T2. This is, sorry, T1 and this is your T2. So T1, T2, T2 difference T1. So what will happen here? Again, this is going to be R x x of the differences T plus tau minus A minus T minus of minus will become plus A. So I have now completed with the conversion of exponential of product of two time parameters as an autocorrelation. Now it is mere simplification of the data which is available as the time difference. What will happen over here? You can notice that you will have plus t minus t cancels off, plus a minus a cancels off. So just your tau alone is going to be left out over here. What happens in the next term? Plus t minus t cancels off, tau minus a minus a. So what will happen to this quantity? You will have tau minus a, which I can write it as tau minus 2a. Now coming to the third factor, what I will be having is I will have plus t minus t to cancel off, and what you will be left out with tau a. So what you have is tau plus a plus a. So you have tau plus 2a. So this is my quantity left out. Moving on to the last term, t minus t cancels off, a minus a cancels off, just your tau is left out. Now you can see that the first term is Rxx of tau. The second term is Rxx of tau minus 2a. Third term is Rxx of tau plus 2a plus Rxx of tau. So when I go for the expansion, what we have finally is that we have the final answer to be arrived as this first term, the second term combined together Rxx of tau. This is your Rxx of tau. So you will have 2 times Rxx of tau. The next term is minus Rxx of tau minus 2a, which is present over here. The next term is minus Rxx of tau plus 2a, which is present over here. So the problem is very simple. What you'll have to do is just consider the product of your y of t and t plus tau. Take the time difference. When you subtract your time 2 and time 1, you will be getting the value of your tau, and the tau on combination will give you the required results. Thank you.